Well, series connection, parallel connection, mixed connection. In this video, I want to try connecting two different incandescent bulbs in series. In a series connection, the same current flows, and in a parallel connection, the same voltage. In this case, one is 230 volts with a consumption of 100 watts, and the other bulb I'm going to connect in series is 12 volts and 5 watts. If we apply Ohm's law, 5 watts divided by 12 volts equals 416 milliamps, and the 100 watt bulb equals 100 watts divided by 230 volts, giving us 434 milliamps. Well, only 18 milliamps of difference, so it's manageable. So, since they have similar currents, connecting them in series won't cause any problems? Would they just distribute the voltage correctly? The 230 volt bulb would subtract approximately 12 volts that would fall on the other bulb, and the current would obviously be the same. Okay, I'm going to proceed with the connection. Oops, it's blown. I have to say that I've already done these tests, and sometimes they work well, and other times they work poorly. I'll explain why the 12 volt bulb blew. Let's see if you know that I'll explain it now. I'll clear up any doubts that let's measure the resistance in a vacuum, that is, without voltage. The 100 watt bulb gives us 35 ohms, and the 12 volt bulb gives us 3.8 ohms in series, which is 38.8 ohms. So, applying Ohm's law, 230 volts divided by 38.8 ohms gives us a result of 5.92 amps. That's the current circulating at the first instant. So what happens is that the 100 watt bulb takes longer than the 12 volt bulb to increase its resistance with heat. With this circuit, I'm showing you the instantaneous initial current peak using the oscilloscope. So the resistance of the 12 volt bulb increases to 40.34 ohms, and that causes the voltage across its contacts to be close to 126 volts, which is why it burns out. I have an idea. Since a filament of the 100 watt bulb must be hot to reach 529 ohms, I can use a switch to start the 100 watt bulb first, and then connect the 12 watt bulb in series. Well, a switch that short-circuited the 12 volt bulb would have worked just as well. Well, it works. You see, it works. Connecting a 12 volt bulb in series with a 230 volt bulb works if the current is the same. And if it worked with a 12 volt bulb, connecting 10 24 volt bulbs in series connected to 230 volts should work, right? It would support up to 240 volts. And while I'm assembling it, I'll tell you what can be done with a 230 volt, 100 watt light bulb. There's already a video on YouTube that explains it. The problem is that it will always supply almost half an amp, regardless of the battery's charge level. If the battery is fully charged, it will continue to supply that half amp until it fails. Furthermore, it doesn't work for all batteries because, as we've seen, the first moment supplies almost 6 amps. So, it must be done with large batteries, and, of course, the battery voltage must be monitored. So, as an emergency solution, it could be useful if I'm giving advice. I would prefer to put 9 1.5 volt batteries in series to charge the battery, but I'll explain that in another video. 100 watt light bulbs are useful for connecting them in series with circuits we need to test, or motor coils or transformers. That way, if there's a short circuit, nothing will happen. The bulb will simply illuminate at 100%, as long as the circuit being tested doesn't consume more power than the bulb under normal conditions. In that case, we would use a 200 watt bulb or larger.